Hello, good afternoon. It's a pleasure to be here with you guys. My name is Bruno. I'm from futurice, and I'm coming to talk about public cloud and making a walkthrough, an overview, and their AI capabilities. Quick words about futurice and myself. Futurice is a software engineering and innovation consultancy, headquartered here in Helsinki some years ago, now spread all over Europe. We are a company of 550 plus people, and we are seven. Actually, the slide is out. We are 8 offices because we just launched a new one. Um, and yeah, quick words about myself. I'm a principal architect and technology advisor at futurice. I'm Portuguese native, based here in Helsinki. I work mainly on the domains of architecture, cloud, security, DevOps, and AI, which are very wide, as you might imagine. Um, I love coffee. I don't know why that's relevant, but I'm pretty sure it is. At least to me, it is. And I love music. I enjoy traveling, and I like indoor climbing. Um, so the topic is public cloud and their capabilities. But when we think about public cloud in the context of AI, in the past years, AI advanced a lot thanks to public cloud. If you imagine that it was unimaginable like a couple of years ago, 10 years ago, you wouldn't have access to the computational power that you have today. Right now, for the cost of a coffee per hour, you have a huge computational power. So a couple of euros per hour, and you can do unimaginable things. And so this public cloud and infrastructure as a service, and also platform as a service, has been evolving quite rapidly. And as a technology advisor and architect, one of the questions that our clients do is like, hey, which public cloud should I use? There's so many things out there. All of them have many, many services. And it's very, very fuzzy and unclear. And my background, I have strong expertise in AWS, but in the past year, I've been working more and more in Google Cloud and Azure. And while the three of them, they are the most popular, we'll dive into that. But actually, a bit show of hands from here, like who uses, for instance, or has experience in AWS? Raise your hand. Okay, what about Google Cloud? One lonely wolf. Oh, two. What about Azure? All right. What about no cloud at all, no expertise? All right. So I will keep this agnostic as possible, and so don't worry about that if you've never used any of the public clouds. My aim is in the next 20 minutes or so, you get a good overview of the three of them, Google Cloud, Amazon Web Services, and Azure, and you can actually understand a bit what are their capabilities in a really, really high level. So why these three public clouds? If you look at the market landscape, the three of them combined, they have 70 to 80% of the global market. So from everyone using public cloud, meaning infrastructure as a service, platform as a service, 70 to 80% of them are using one of those three. And if you look at those, 40 to 50% of them are using Amazon Web Services. It's a huge number. And this data is from 2017, so the things have been already changing a little bit, but not that much. What's happening actually more and more is that the market is consolidating around these three of them. In the past, actually from 2017 to 2018, which were when we have the most data about, for instance, from Gartner, two really important things happen. One is that Gartner basically dropped from this magic quadrant, they dropped 9 players. 9 companies that were providing public cloud were completely dropped from this. And the other big change is that Google, for the first time, was classified as a leader. Previously, 2017, they were here on the, on this bottom quarter as a visionary. So now you have a very polarized spectrum that you have on the leader, you have 70 to 80% of the market share, and niche players, you have the remaining. And a couple of words about Amazon. And this is a very high level view and And in a way, it's my experience and my gut feeling towards that based on what I've been seeing so far. So it is my opinion, and take it like that. It's not Gartner's opinion or anyone else. So Amazon has been market leader year over year. They were pioneers in the industry. And one of the things that they do extremely well is that they are extreme customer-centric. They really are fanatic towards customers, regardless of the size of your company. I think that's one of their main characteristics. They are, generally they are really good at providing services and doing the heavy lifting of things that you could build by yourself, but you don't necessarily don't want to. An example of that is like databases. You can, build a database in public cloud by yourself, but you don't really want to because you want someone else to manage that for you, usually. And they are very stable in terms of their services, in terms of their SLAs. And they built their whole public cloud a bit from, and this is my personal opinion, but from the ops towards devs point of view. So from more like operations perspective rather than a developer experience type of point of view. And when you think about Microsoft Azure, well, one of the really impressive things that they are gaining market share very rapidly. So they are now in the 30% of market share, which is amazing for them. I think actually they are the number 2 globally. I think there's in pretty much all the continents except of Asia. In Asia, there's the number 2 is actually Alibaba, which is not on this tree, but it's the only market where they are actually even appearing on the top 3. But Azure is gaining a lot of momentum. They have a really solid and good offering, a value proposition, especially if you have a hybrid environment. And by hybrid environment, I mean that you are using either on-premise data centers and public cloud or different public clouds. And that's actually their strategy to make it easier that you can use them or you cannot use them. And that's kind of the feeling that you have towards them. Like they don't make it this kind of, even though it's Microsoft, which is kind of interesting, they struggle to not providing this vendor lock-in in a lot of the things. And about their regions, all of the 3 of them are, spread all over the globe. But when you look at the regions that they provide, like in the map, 2 things that are a bit different from Azure. One is that they, especially for us here in Finland, they classify as Europe North region, and actually Europe North is actually Ireland, UK, and Germany. So they forgot the Nordics. Not really, because they're actually opening a data center or a regioning in Oslo quite soon, but it's still it was a bit shocking to me that they are still classifying that as Europe North. And also that one region has 1 or more availability zones. And this is especially important because when you look at the other public cloud vendors, there's like Amazon or Google Cloud. Usually you have, in each region, you have at least 2 or more data centers. So, and in Microsoft, that's not the case. They have at least 1 data center. And when you look at the map, it looks that the infrastructure is a lot bigger than the others, but it's not when you take this into account. Things that look really interesting in Azure. Service Fabric, I will discuss about that, but Service Fabric allows you to run containers both on-premise or in other clouds and in Azure. Azure DevOps, and by Azure DevOps is their solution that allows you to do continuous integration, continuous delivery, version control system all in one. It's really, really interesting from the sense that everything is very integrated. And Resource Manager template, it was something that really caught my eye. It's very similar to CloudFormation, if you know Amazon. So it allows you to define your infrastructure as code. But the impressive thing on that is that they can generate these templates after you do the things manually. Although I heard from some colleagues that tried it quite extensively, that feature, and it doesn't really fly when you want to do some more advanced things. But it's still a very interesting concept. And then Power BI, which is their analytics and reporting tool, which, funny enough, is actually not part of Azure. And that's a common misconception, meaning that Power BI is actually part of your Office 365 offering. but is deeply integrated with Azure. But it's very, very powerful and very, very interesting as a tool. Now, Google Cloud, Google has, based also on their history, they have a strong focus on innovation and providing things that you cannot reasonably build by yourself. So think things like big data and global scale type of services by default. And they build it with a developer point of view, meaning that they have all of this concept of site reliability engineering. And it's very clear that when you are using Google Cloud, that this concept is very, very there. Like they made it for developers with this in mind. And based also on their history, they have been like services, they have services that they either released it as open source or they just commercialize. Meaning that, for example, Kubernetes, which is now quite big this year for some reason, but it's a really interesting service, but it's gaining a huge dimension, almost a buzzword type of dimension this year. And Google was the one that open sourced it in the first place. And they do provide it. They have a service like Google Kubernetes service, but it's fully open source. On the other hand, they also have services that they didn't really open sourced, like the Dremel, but they commercialized it and you can use it only in Google Cloud, which is now is known as BigQuery. Things that look super interesting in Google Cloud, they have this pub/sub service, which if you are from Amazon world, you can picture as SQS plus SNS plus Kinesis all in one. So it's a very powerful, only one service that can do all of those functions. And also very interesting that a lot of the services were designed to be global by default. They have really interesting AI and ML offering capabilities. Well, we'll go through that a bit in the next slides. And they are a bit, in my opinion, a bit ahead of the curve on those capabilities, even more than Amazon. And they are the only of the three that have a data center in Finland, which for some companies that's quite relevant. But if you don't know anything about public cloud, or if you are only using one of them, you are usually quite immersed on that world of one single vendor that you don't really pay attention to the others. So when I started to do that, my mindset was like Amazon, and I had to translate that to the others too. And it was very interesting that there's a lot of similarities. And I'm trying to do this as neutral as possible. But there is something that I think is really interesting in the way that Amazon approached this on how to classify their products. I know there's a lot of information. This is just a guideline. Amazon called these 4 blocks as the foundational blocks, meaning that all of the 3 vendors, they have hundreds, thousands of services that they provide, but they all, one way or the other, were built around those 4 building blocks. And those building blocks are the compute, the network, storage, and identity and security. So if you think like, for instance, databases, in all of them, they are usually built from these 4 building blocks. So they build their products based on their products, in a way. And when you think about compute, and there's usually a couple of things that you are looking for. You are either looking at virtual machines or instances, and in the 3 of them, this is very similar concept. They exist, obviously. In Amazon is EC2, in Google Cloud is Compute Engine, and in Azure is virtual machines. And then you are looking at things like, I want to run containers. And on this part, a couple of notes that are relevant. One is that basic Kubernetes as a service is provided by the 3 of them. And that on Azure, there's this service fabric that I mentioned, which is kind of interesting from the fact that you can run a container in your own data center using the service fabric or on Azure. And I think that's an interesting concept if you have a hybrid environment. And in Amazon, there's the Fargate service, which is also very different from the others in the sense that you have a container and you just wanted to run it. And you don't want to have any kind of, you don't want to configure any clustering or anything like that. Also, in terms of compute and serverless, there's of course, everyone that works with serverless knows Lambda. Lambda is function as a service, meaning that you have a piece of code and you want to run it. And in that, Amazon is really a pioneer. I think the others do have it. Google Cloud has Cloud Functions. Azure has functions. But they are a bit behind Amazon on that. And then there's the fourth part on compute, which is application deployment, which is very interesting and a bit hard to explain. But actually, Anthony was mentioning about that with the Elastic Beanstalk, that you want to you have an application, you want to package it and run it. A bit similar to Heroku. And on this, Google did an excellent job, and they have this service called App Service. And it's very similar to Heroku in terms of easy to use, and is also with the all advantage that is very integrated with Google Cloud. And it's in that sense, it's miles ahead of both Azure and AWS. And why I'm insisting a bit on the compute, because it's a very foundational type of block. But on the network level, they are also, they are very similar. And meaning that you will usually have this VPC, virtual private cloud. You want to build your own private cloud within the public cloud. You need DNS, you need load balancing, and the three of them offer that type of service. In storage, you are looking usually for block storage, object storage, and elastic file storage, meaning a block storage you can picture as a hard disk or a persistent hard disk, and block storage, object storage as this is actually hard to explain. Object storage you can picture as you have a binary that you want to put and get. You don't want to care how it's stored. You just want to have an easy way to add files and to retrieve files. And elastic file storage you can picture as a network share, that you just put things there and it keeps growing. And it's a network drive that is connected to your instances. And the three public clouds offer that quite well. And also security identity, very, very similar, that you have this IAM type of concept, which means that you can create security and roles, permissions based on resources, and those are really similar. So if you look at this picture, and if you are trying to decide which public cloud to use, you actually don't know, because they are actually very similar just based on this. Of course, if you have a couple of things that will benefit, for instance, for Lambda or from app service, you will maybe influence your decision on that. But on a core level, they are very similar. And now, when we think about AI, this is where the things get very heated and very, very, very different. And this is where actually a lot of customers are struggling, because they see that on the foundational level, they are pretty similar, but they don't exactly know on the AI capabilities, on the AI services, how do they differ. And one thing that is very common on the three of them is that their AI machine learning services are usually grouped by three subgroups, if you want to call it. And one is, of course, this data engineering things. It's the way that you ingest data, the way that you prepare data, the way to transform data, or making analytics. The other is this AI machine learning platform, as they call it, meaning that where you can build your models, train your models, and deploy your models. And then a third one, that is the one that actually is growing quite rapidly now. It's the AI machine learning APIs, meaning that pre-trained models, serverless APIs that you can just use, and you can use that out of the box without actually needing to do anything. On the data engineering level, when you are building this data lake, data warehouse, it's often actually very similar, that you need to have a set of steps. And even though these are not the only tools that each of them provide, it gives you a bit of how you could do this with them, meaning that you always need a way to ingest data. And usually Kinesis, actually in the talk before, that's exactly how they were doing. And in Amazon, in Google Cloud, you probably use some PubSub. And in Azure, there's event hubs. And then you need to transform the data. You need to or prepare the data. And that might mean that you will do some map reduce or that you're just making really simple transformations. And on that level, Google Data Flow, it's really, really interesting. It's a complete serverless way, although it's very, very similar to Glue or to Azure Data Factory on that level. So up until this moment, there's really very little kind of variance on that. Some services are more mature than the others. I think that's maybe one important thing to consider, that, you know, clearly Google Cloud and Azure have been trying to catch up to Amazon and ramping up their services. And that sometimes you see that there is a lot of, they try to provide the same type of service, but they are usually in preview or alpha or beta. So the maturity of them, of certain of these services, is not as good as Amazon, but this can also be an advantage, meaning that the fact that Google Cloud and Azure are now doing this, they are sometimes fixing some of the mistakes that Amazon did, meaning that Amazon, when they made the concept of the product, they maybe didn't thought about certain use cases or certain things. And now Google Cloud is very clear and Azure very clear that they are trying to make it the right way because they are seeing how people were using the Amazon services. And I think that's very, very interesting that they do certain things in a better way, but they are less mature. I think that's the key thing. Then, well, data warehousing and machine learning platform, the three of them, I will actually dissect a bit these machine learning platforms that they provide in the next slide. But in terms of analytics, also very similar that the three of them, you know, in Amazon you have QuickSight, in Google Data Studio, and in Azure Power BI, meaning that you can easily create nice visualizations and dashboards based on your data. They make this, all of them make this as a service to you, and make it very easy. But when you think about the, you know, the machine learning or the AI platform, things get very, very different on this part. Well, one common thing transversal to the three of them is that all of them, one way or the other, provide TensorFlow. They all mention TensorFlow across them. Then some of them mention PyTorch or Keras. They change a little bit. I think that Amazon maybe makes more fuss that they provide more of these services all in one. But I think to me the surprising part was that, or unsurprising maybe, but that TensorFlow is in all of them. And if you use TensorFlow, you will be happy with any of them in a way. Then when you think about the, in a way, the machine learning APIs and what I was talking about before, that this is ramping up very quickly in the past 2 years, is that, and this is where the things get very, very, very different across them, meaning that Amazon was a bit pioneer in that, in giving things like Lex or recognition. And Lex is a chatbot, so it allows you to create easily chatbots or intelligence chatbots. And nowadays, all of them have. So Google Cloud has Dialogflow, and Azure has bot service. And then Amazon also launched recognition. And recognition is basically image recognition. And of course, all of them kept following. But I think at some point in the past year or so, Google Cloud started to really crank up a notch and providing a lot more functionalities. For instance, even though they all have this kind of like, you know, text-to-speech or automatic speech recognition, OCR, translate services, when you look, for instance, at the languages that they support, it's very clear that Google has a wide support of multiple languages compared, for instance, with Amazon. Azure, for instance, it's a bit, I'm a bit hesitant to say this, but it's a bit like marketing, that they tell that we have this just to go like check. But in terms of real capabilities, once you start using it, it's a bit far behind, like miles away from what both Google and Amazon provide. And then more and more this type of APIs are being provided to a bit unusual services. For instance, Google Cloud provides something called Genomics, which is for you to easily store and process genomes, like human genomes. And it was a bit surprising that they even have that type of service. So they are really evolving into really this kind of very atypical type of services. And the cool thing is that you can use this, you make a simple API call. In a couple of milliseconds, you get a lot of information from, like for instance, if you use this NPL type of services, you can see, and you submit the text via that API, you get a sentiment analysis of what that text, what Google or what Amazon think about that text. I think that is quite powerful because it allows you to build up quite quickly and ramp up and do a lot of interesting things without you actually having to do the data science. I know that most of you are data scientists, but machines are taking your job as well. It's not just developers. I'm joking, but kind of. But it's true that you guys can actually do a lot more because with this type of things, they will not solve all the problems, obviously. But I think the gist of that and why people are adopting quite well these APIs is that it allows you to maybe to focus on the harder problems rather than the easier problems. Because the easier problems, Google and Amazon and Azure already did for you. I think that's the thing. That's all I had to say. I hope that was this not massive overload of information and that you actually got something from this. I'm happy to answer any questions that you may have. Thank you.
First is that how easy it's to use like all of the three clouds and pick the best parts of each. And the second question would be quite specific, that if you have some kind of like manufacturing process information and you would want to apply some kind of predictive maintenance kind of learning, which cloud would you use for that application?
All right, thanks. Well, the first question about the easy to use, the three of them are, and there is clearly maybe a more, you can easily sign up for them for free and you get actually some credits, meaning some money that you automatically that you can use. A lot of them have a lot of free services, but there's clearly maybe more muscle put behind Microsoft and Azure, meaning that they provide you, I believe it was like $300 and something for 12 months. No, sorry, for 1 month, but a lot of the things will continue to be free. Also, Google has been putting a lot of money. They don't want to fall behind. You also get around $300 for free when you sign up. Amazon, not that much. You get 1 year up to free services, but they don't get you this. They don't really get this money to play around with the paid stuff. They are, the three of them very easy to use, easy to integrate. Maybe one note on that, and I'm glad that you asked that question, because people usually on the Azure, a lot of clients have been saying like, I have Office 365, it seems very natural and I can easily use that. And while it's true that you can easily use that, with Office 365 you can use any of them. Meaning that you actually don't get a significant advantage of using Azure just because you have Office 365 from the technical perspective. Of course you might get a better deal with them, that's a different question. But no, the three of them are really easy to start exploring. You can already do some creative things already from day one. On the second question, it's a bit tricky to answer it because the natural consultant answer is it depends, because there's a lot of factors to be taken into account. But on data engineering, because that's the core center of that, usually when you make this AI machine learning projects, a lot of the time is spent actually on the data engineering. And in the three of them, you still need to do a lot of things, but I will say that Google Cloud or Amazon will simplify them a bit more than Azure from that perspective. But the three of them will do the job. I think it's the amount of effort that you need to put, especially in the beginning, is quite different.
Thank you for the talk. It was very illuminating. So this might be a bit tough, but to summarize all of these, do you have a specific use case in mind for each of these where you would clearly prefer one of these over the others?
That's a hard question. Well, the things that I have my personal preference, obviously, but especially with clients, I need to be as neutral as possible. And I think that's one of the things that they demand, and at least I'm proud of providing, is this neutral rationale behind each of them. Usually, some companies are very tied to a particular cloud, but at least in futurice, everyone is using pretty much the three clouds, although there is more expertise in Amazon because it's more dominant in terms of market as well. But we have expertise in the three of them. Now, I'll say that with the three clouds, you can do pretty much anything, meaning that the amount of effort is very different. And effort in the beginning of a project and effort in maintaining it. So if you plan to not have operations or developers in-house to maintain certain service, I will say that you might be better off, for instance, with Google Cloud or with Amazon, depending on the service that you are trying to do. Especially because they have a lot of, in terms of serverless capabilities, they have a lot more, I would say. But yeah, I think, for instance, in AI, I would prefer to use Google Cloud or Amazon rather than Azure. If I have a hybrid environment that I plan to be hybrid, I will probably use Azure on that. So I think that answers your question, but that's my personal preference. So it really depends on multiple factors.
Yeah, I just had one comment. I also started using Amazon first because it's most popular one. But recently I've been using more and more Google Cloud, and I really, really like the fact that it's way easier to use, at least for me, when I'm coming from a statistical background. I don't code that much, or nowadays I need to, but, and I was just setting up last week an R function in Amazon Lambda, and it was pain. It was so much pain. Our CTO is on a holiday. But with Google Cloud, it's just, at least their tutorials are more up to date, or then they are more easy to follow and just click through. So kind of a beginner's, I don't know, tip. Azure, I don't know.
That's a good insight. Maybe just allow me to make a follow-up on that. When I was learning and getting hands-on experience, I found that, for instance, Microsoft, they have a really, really good learning platform, meaning that one of the things that I thought was amazing how they did it was that they, alongside the reading, they actually have a sandboxed environment that you are actually live trying those things in the same window with the live system. So that was really interesting, but those are like very basic type of commands. Google, they have really excellent things, for instance, in Coursera, where you can actually learn. So you can go very deep, very quick. And Amazon is a bit mixed. You can learn a lot from, you can go to the deep details on the documentation, but when you want an overview, it's a bit harder to get. Yeah.
Hi. Inspired by his question, actually, would you strongly recommend against mixing clouds? So if I would perhaps want to load my data using Kinesis, then store it in S3, but then ship it off to Google Cloud for doing whatever I want, and then doing something else on Azure, is there any interoperability things provided for this kind of thing, or is it I shouldn't be doing this ever?
Good question. It's not a question that I usually get a lot. and there's there's different opinions towards that. I think that it's perfectly fine if you want to use different clouds, but I wouldn't use different cloud for a specific service. Meaning that if I have a specific service, I wouldn't divide that service in Amazon and Google Cloud. But from a company perspective, that is fine to do it. Meaning that, for instance, let's say that you are using Amazon and you want to use Google Cloud for AI data lake type of things, as an example. There's a bit of it's less problematic to do so. However, you need to consider not just the technical factors, but also the management factors, from the sense of, if you create a good expertise in your company about a certain technology, you get a bit an extra advantage from people knowing that and be able to talk about that between themselves and learning together. The other is that it's fairly easy to connect between clouds, either by private endpoints or public endpoints. But by doing so, the security model changes quite drastically, because you cannot use things like, for instance, IAM, which is a common thing in all of them. IAM applies to resources within that particular cloud. So if you want to use something that is outside, you cannot use IAM to protect them. You will need to use some like access key and stuff like that to access those resources. So those are things to be taken into account. I think that's, but meaning that personally, I will only use that if it was company level, not service level. And even company level, it depends.